While we're here, are there other topics of interest to people? Chip is here. Any items that want to be discussed briefly?
I could show my test setup for the P2 cube.
Okay. And what else do we have? How to do true random on the P2? Anything else? Chip, did you have any particular topic, or are there any support needs out there?
Well, I have some pictures of the latest Edge that Michael Mulholland sent us this morning.
Okay. All right.
Nice.
Saw those as well. Anything else for anybody? Well, why don't we look at Stephen's test setup then for the P2, and then we'll look at the Edge new images, Chip, and you can tell us about that.
All right.
Okay. I have, I'm just basically sharing a web page. This is up at my GitHub repo, and I put a link at the initial start of the discussion. What you're looking at here is 6 panels wired together. They consume 8 amps max each, and so I'm actually driving it with a 60 amp 5-volt power supply. And there's our P2 in the corner down there. And when you drive it and specify to the driver that's a single panel, you get the same image shifted down by 1 row as you work your way left across the panel. And so that's what the hardware's working. And so what I found out is that I can drive 1 or 2 panels really well, but 6, my placement of the bits in time is incorrect. And so I'm actually correcting that now. So the next release of the driver will actually respond to the number of panels correctly and display the output correctly. And that's about all I have.
Did you say 60 amp 5 volt? Did I hear that right?
You did.
What does that power supply look like?
That's
Just a
it.
bench?
That little
Oh.
box in the corner.
So
Yeah.
it's a lot of current at 5 volts.
Yeah, sorry, I just clicked on the picture. Thanks. Why did I do that? I had no need to click on that picture. Let's just make that go away. Yeah, this thing right here, it's a fan. And so when it's giving me the ability to produce that much power, it has a fan on. These things sit, when they're doing like the text display that you see below, they're only drawing 0.3 of an amp per panel. But they can, when I do full white, all the LEDs turned on with no PWM, they will consume about 8 amps per panel. I have each pair of panels driven by 1 set of wires. And so what you've got is 3 sets of wires down to three different things. So essentially each set of wires is doing 20 amps max. I only need 16.
Wow.
So that's how we're doing that. That's just so I can practice driving everything at full rate. When we actually put it in the cube, I'll put a brightness limiter. We'll configure that in the driver so we don't try and draw too much power from our batteries, so they last a little bit longer.
Well, speaking of putting in a cube, I hate to see this demo get torn down.
This one?
Well, yeah, because you have this clock and this scrolling text capability, probably, right? Some demonstration of the driver that isn't going to be possible when these panels get repurposed.
Well, yeah, this I may just keep this linear cube for a while. Other people can do the cube. This becomes now 64 times 6 by 64 scrolling display now at this point, where my driver is capable of putting scrolling text across the entire thing, or scrolling fields anywhere on it, along with static fields or video fields. We'll be able to do ultimately. So this could be a long display displaying, doing a lot of individual statuses if I wanted to, of various different things around my house. So heaven knows how this will be tested ultimately.
Well, I'm hoping you can come to Parallax 10 months from now.
Yeah, I saw that note. That'll be interesting. And yes, I'd travel with whatever we could. So
Any questions for
probably.
Stephen?
Go ahead.
Yeah, any questions for Stephen? Comments? Keep going.
Yeah. I know you.
All right, Chip. P2 Edge.
E2 Edge.
You might want to show
let's
these
see.
guys what you just put in shop a few minutes ago.
Oh, yeah.
Of it.
This morning's been crazy. This is like the biggest day of the year here. All these people showed up. Even Michael Summer came by. You know, he's the guy on here, the German guy, and he's driving right now, but he picked up a bunch of walnut wood from me and we planed it. And I have like not itchy, it's like acidic sawdust down my shirt now because that planer just spits chips everywhere. Anyway, then we moved in Doug Pintack, who we've worked with at Parallax in the past. He's renting part of our shop here. So we moved in a big Haas mini mill 2 and a Haas lathe. And those are getting set up tonight. And then tomorrow, the guy from the factory is going to come out. And so that stuff will be working. I don't have a picture to really share. I just have like it's just in the room, but all day, everything been opened up here. People have been running in and out and all this stuff's been coming together. I wanted to talk to Michael Mulholland today about this, but we didn't connect. But I'll show you the, let's see here.
Those mills are supposed to help us
got.
get our own production up to speed because we are perpetually behind with CNC parts.
Nice.
Yeah, we're going to give Doug quite a few jobs to do.
We can show a quick picture of that chip. Here they are.
Do you have a picture, Ken?
I just brought it up.
Yeah.
So that's a VF2 mini mill and then a CNC lathe. And I think that lathe has some milling ability as well, doesn't it?
Yeah, Doug wants to put some light tooling in the bay, or not some live tooling, so that he can like cut flats on things. That mill is pretty interesting. It's very simple. It just has this spindle that can feed material, and then it has all these stationary tool rests where you bolt your tool down, your cutters and parting tools and all this stuff. Even like you can just take a tap die and bolt it down, and the spindle can like spin the workpiece into either a drill bit to drill it out and then back it out, and then like time the sequence of the spindle excursion and the rotation, clockwise and counterclockwise to just take a little thread, like a little tap, and thread a hole in something along the axis of the material being cut.
It's like rigid tapping.
So it's actually
rigid tapping.
It's moving the workpiece itself, not the tools.
Right. So imagine, you have a little tap tool, a little, looks kind of like a drill bit, but it has these flutes and cutters on the sides.
Sure.
That thing just mounts stationary, and then it moves the workpiece. Like it'll rotate it in, stop, rotate it.
That's wild.
It's really simple the way that thing works, but it gets the Jaws guy is going to be out here tomorrow morning to bring the big machine up, and then also look at the Haas mill, because there's a problem that it won't go up to, it's supposed to be able to do, I think 6 or 10K RPM on the spindle, but if it goes over 4, the whole machine shuts down. There's some kind of problem. It might be a power supply issue.
I think it depends what kind of
but
tool
in our
you're
shop here,
throwing.
we've got all these. Yeah. Doug got that machine. He was planning on putting it into his garage, but it would not have fit. I mean, that thing was way too big. We had to even open the doorway to get it into the room. And here we have all these 208 3-phase drops. So it's very easy to hook all this stuff up. And we have air drops in the ceiling. Everything, it was from the tortilla factory. So we're all equipped for lots and lots of power. So it's ideal room for that stuff.
Okay, not to point a gun at your feet and make you dance, but I just ordered 100 of those hoverboard motors. So the clock has begun for you guys to give a useful motor controller, and then Doug will start making the bearing blocks on this machine, and hopefully the pieces can come together at the same time.
Yeah, I just, as John was finishing up, I was coding up a little thing to read here's that hoverboard wheel, right? And then the Hall effect sensor comes down here. I have it plugged into a Johnny Mac board, but I've got 5 volts on the red line, ground on the black, and I'm thinking that the other lines are maybe,
Restart your video, Chip. I accidentally turned it off on you when I was trying to
oh, that's what
spotlight it.
happened. Okay,
Yeah. Sorry.
that's fine. Anyway, I'm not getting like sensible waveforms on the scope. It looks like things are blurred. Has anyone ever used the Hall effect sensor on these motors? Because it doesn't look like you just power ground it and then pull it up. I mean, pull up the three data lines. Anyway, I'll work that out. I was just curious as John was finishing up. So let's see here. I'll share the screen. There. So where do you see the big writing that says P2 Edge? For the PS RAM version, there's going to be 4 of those 8 megabyte SRAMs in this area. And then for the normal one, it's just open. But down here, do you see this little thing that says 20.0?
Yes.
That is a temperature controlled crystal oscillator that's like 500 parts per billion accuracy.
Jeez. Okay.
It runs at 1.8. So we run it, and it's only like a 0.8 volt peak to peak signal that comes out of this thing. It's this clipped sine oscillator that JMG is always talking about on the forum. So we run it through a series cap to, isolate the DC level. And then we have an inverter. This little 6-pin thing is a dual inverter. So it has a feedback from the input to the output. And then we couple the cap that's coming from the oscillator into that thing. So it brings it up to a full, 0 to 3.3 volt, really fast skewing logic signal. So then that can run right into the XI pin here. So we're going to fix this problem of noise on these last 4 IOs, jumbling up the PLL by really sharpening up that edge. And we have a nice TCXO that's going to be super accurate. So we can do things like take that counter that can pretty quickly measure period and frequency. So it'll be like almost instrument quality. We could get a VTCXO and then fine tune it, but then we'd have to have some kind of super calibrated reference to even adjust it by, which we don't have. But anyway, so that's the clocking scheme's a little bit better. The LEDs are in the same place, but you see the dip switch moved all the way over to here where it says LF up and down arrow.
Mm-hmm.
I don't know why it didn't render the dip switch here, but that's the dip switch. The flash is next door to it. And then importantly down here, we come in through a PMOS. It's amazing. I notice these days, these FETs have insanely low on resistances. And so people can make these little boards for motor controllers using like SO8 FETs that can handle 500 watt motors. I mean, that's pushing a horsepower, through nothing. I mean, I personally don't see how the PCB is up to snuff. But anyway, we run through a PMOS FET here, just so we have reverse polarity protection. And then we have this cap is just a cap to ground. Then we have an inductor and then another cap to ground. This forms kind of a pi filter to stop noise from coming in or going out. And then we have 2 identical switchers, but different set resistors for setting the voltage. So one of them generates the 1.8 volts for the core, and the other generates, I think, 3.8 volts, which then gets regulated down by all those LDOs down to the local 3.3 volts. So this thing is going to be able to take in 5 to 16 volts instead of just 5 exactly. So it's going to be a lot more robust for industrial apps.
Chip, is the board
Oh,
gonna
and the last thing you see up here, this. Say that again?
I'm sorry, is it going to have a 5-volt voltage on the board?
Well, you can run 5 volts into it to power it, but it doesn't have 5 volts that it outputs at all. You can run
Okay.
5 to 16 into it to power it. But it will only output the local 3.3 volt supplies for each group of 8 pins. So the 1.8 volt never leaves the board. So you just put 5 to 16 in and you get a few 3.3 volt outs.
How did you come up with a 16V top?
I think Michael did a lot of research on what's available and what there's a lot of that we're not likely to run into a problem of long lead time with.
Oh, gotcha.
And it just came out that these parts, I don't know if they're second sourced or there's just a heck of a lot of them at DigiKey, but they have, we wanted a wider input range. We wanted to certainly be able to do 12 volts, no problem. So it was just kind of what he decided to do. And these also have integrated diodes. So all we have on the outside are the input and output caps and the inductor.
Nice, nice.
And so we're not, and these are molded inductors. We're going to get rid of this ferrite core one that we have now that tends to chip and break and lose its quality.
Right.
So these are molded.
It's going to be good. It looks great, Chip.
Thanks. Yeah, Michael's done a great job, and we went back and forth. We've discussed this over Google Meet for like probably 20 hours over the last week or two. We kind of reviewed every bit of it. And he's got this down to 4 layers now. It used to be on 6.
SD card socket, Chip, that'll be installed.
The what?
SD card socket.
Yeah, if you look up here on the left, this big silver thing is it's a micro SD socket. And so it has, to get something with this small of a footprint, it has its legs underneath the package. So we have to put it on when we reflow it. It's not something a customer could apply later and solder because he'd have to reflow the whole board. So we put that on up here, and you can turn the flash off if you want, and it just pretty much disappears from the circuit. So you could boot from SD.
So
And
then you're going to be selecting between the one or the other, or is this just boot selection?
I think you could do both. I'll defer to Ray because I've never fully understood. Like, I know there are time delays because it takes a while to talk to an SD card. So Ray, what's the deal?
The deal with the SD and the flash is that I've, at the end of a command sequence with the SD card, you need to send FF before you drop chip select, and then you need to send another FF afterwards, and that gets rid of the problem. So, and the problem is that the SD card, many of them keep driving the data outline from the SD card, and you've got to force it to let it go. And by doing both those 2 sequences, so you're sending out 2 extra characters to the SD card at the end of every command sequence, and that will force it to drop the DO as far as I've seen everywhere. So yeah, I've always used my SD cards with other shared devices, like particularly my RAM blade that does Z80 emulation. Now you've got to jump backwards and forwards into the emulation, and it works fine. And I've got the whole SD, the whole static RAM using the same pins. So there's never been a problem for the last 10 years. So it's not a problem. And if there's a problem, then we just got to fix the software.
Are you saying though that, okay, the reason I defer to Ray is because I don't actually know, because he wrote the code that went into the ROM of the P2 that handles the SD. So
Okay.
Ray, are you saying that this sequence the ROM code is doing, or it needs to be done some other way?
I believe I think I found one hole if you come in a particular way in the code that I hadn't corrected, but I don't think that's an actual factual problem. I think it's a contrived problem to get to that place. So I'm confident, and I'm certainly using it at the moment, although I'm not exercising the flash chip at the same time. But yeah, I believe the problem's resolved in the
Okay.
in the second rev of the chip.
Yes. Okay. That's what I was hoping to hear. Okay. Good.
Yeah, the first rev did have a problem.
Yeah. Ray wrote the SD booter, and then, Peter Jakaki wrote the Tacos, the fourth engine.
Nice.
When you
And
say
then
the second rev of the chip, do you mean the rev B?
Yes. Rev B and then Rev C, the same thing.
Yeah, we wrote the A, and then I tweaked the SD card. Peter tweaked the tacos for the Rev B, and the Rev C is identical. It is a mask only change on the die.
Yeah. Yeah. So
Chip,
if there's
just a question while you talk while you're on the edge board. Did you try the oscillator in my retroblade board? Because I really think this is an overkill, and you're tending to tell engineers that they've got to put that whole circuit on, whereas I'm not even using an oscillator, and I don't have the problem.
Yeah, I would like for that to be the case. I mean, I'd rather not put all this stuff on here. But the trouble, well, what we did is we experimented with a lot of stuff, and we found that even if you have an arrangement where it's not happening, it's still almost happening, because we can see a lot of the telltale spikes on the XI and XO line because of what's happening with the internal power supply rails. And so I believe your board doesn't have the problem, but I also believe it just barely doesn't have the problem. And so we just
have you physically looked? Because what you're telling engineers here is that now you've got to put all this stuff on the board, and that's a big downer if you don't have to.
Yes. Well, if you can control what you're doing with those pins, and you're not going to abruptly switch them in logic mode in tandem, a couple of them together, you won't have this problem. But I have not tried your board. Is Ken still on, or did he take off?
Yep, I have Ray's board right here.
All right, could you send that to me? Because I haven't actually
Yeah.
tried it yet.
Keep meaning to bring it.
Do you
to
have a
but I never see it.
CP2102 chip?
No, but I can get one of those.
Okay, you can wire up your just have to put 5 volts onto the board, and you wire up your prop plug onto it. But
Okay.
if there's any issues, just email me. I'll get or send me a text. I think you got my phone number.
Yeah.
If you send me a text, I can go back on in case I'm not on the machine at the time.
Okay. All right. Oh, okay. One thing, Ray, I know this looks crazy, this arrangement we have here. We have a 1.8 volt oscillator that is accurate. Then we go through a level converter to get it to 3.3 volts. Yeah, this is overkill, but here's why we did this. We could just hook a regular crystal oscillator from 3.3 volts to ground and run the output right into XI if we don't want to use a crystal, right? That would just be a one component solution. But all the parts that take 3.3 volts and output 20 megahertz are taking like 7 milliamps. And that's way too much quiescent current. But this little guy typically takes 1.3 milliamps at 1.8 volts. So it's really way less power. It's 1.3 times 1.8 as opposed to, those are milli values as opposed to, 1.3 volt times, 1.8 volts times 1.3 milliamps versus 3.3 volts times 7 milliamps. So the power consumption is much, much lower with this 1.8 volt part. And we wanted the thing, because see, if we don't have a crystal here and we're always running an oscillator, and we don't want to throttle the oscillator because there are issues with trying to do that. So we just want it to just run dumbly all the time, but we don't want it to take a lot of juice. So that's why we use this 1.8 volt part. And then we
Yeah.
have to run it through a level shifter. So the whole effort was to keep the quiescent current down, and then in the process, for a little extra money, we can get a super accurate oscillator. That's
Yeah.
why it's the way it is.
Yep. I'm only using a crystal on that board, by the way, Chip.
You are using a crystal, right?
I'm only using a crystal, yes.
Wait, as in, yes, you are using a crystal.
Yes, I am using a crystal.
Okay, sorry, I didn't understand. Okay,
Yeah.
yeah. And so when I get your board, what I'll do is I'll probe the XI and XO pins as I toggle 28 through 31 around.
Yep.
And I'm going to look and see how much noise I see on XI and XO, because we've found that if you can trigger the problem, you can even do it very seldomly. It's just that event that occurs that causes, it doesn't have to occur super high rate. It just has to occur once in a while, and it will cause the XI to see an extra pulse come in, which then the PLL goes wild over, thinking it's got to jump up to twice the frequency for.
Yeah. Yeah. Well, I don't have the equipment to test all of that, but yeah, if you put it on, I'm curious to see exactly what happens.
Yeah. Okay. Well, next time we have this meeting, I should be able to report on what I saw.
Okay. And if you've got any issues in getting it running, just give me a bell, or I have put on the internet, there's a forum once you got your board, which shows the links and that you'll need to put on it.
Okay, great. And Ken just put a picture of your board up, right?
Yeah, I was supposed to get this to you a long time ago. But it failed, as Ray knows. So there's one version for you, one for me, and there's some connectors too.
Yeah, and there's the crystal over in the corner.
So top on Y1 there.
Yep.
Yeah, so I'll see what this looks like. I suspect I'm still going to see these spikes. I don't know how I wouldn't, but they're not bad enough to cause the problem, the PLL problem that we have on other stuff that we've made.
Yeah, the issue you've got is that on the eval board, because those two lines went direct close together and you can't cut them because they're internal. Whether they're causing an issue or not, I don't know. But it's certainly worthwhile trying, even if you leave your board as is with all of that. At least you can put a note in your thing. This other one will work if you don't pulse whatever. Try and keep it to an absolute minimum for what people need hardware wise, because engineers look at it. Every component adds 10 cents. Doesn't matter whether the component costs 0.1 of a cent. It's 10 cents to fit it.
Right.
And that's 20 years ago, so it's even more. Ken would know exactly how much it costs physically per component. But it's yeah, the placing of a component on a board is an expensive exercise. We ran our own plant in 2000, so yeah.
Yeah, Ken, I've also heard that machining costs have gone way up for jobbing stuff out.
Yeah.
Our friend Millhouse, I was talking to him last night, and he said it's become really, really expensive.
Well, this is why it's good to see those machines in your office, because we're not being very effective with our own right now.
Yeah.
So I am looking at the P2 Edge Bomb right now. I'll have some questions about that because we haven't gone shopping yet.
I saw there was some room on the right-hand side of the board. Is that where you're going to put your Hyper RAM?
Well, it's those PS RAMs, those 8-pin SOIC chips.
Okay.
Four of them will go there, and then we won't bring the pins down to the edge connectors.
Yeah, that's a good idea for the alternative board.
Yeah, a lot of work went into this. So it used to be 6 layers. He's got it down to 4 by doing a lot of clever stuff. Well, kind of like you did with the power and ground. And
Yep.
this is going to save us a lot of money because I don't know, Ken, what were we spending for these circuit boards?
The P2 Edge before?
Yeah, just the raw PCB.
Okay, the PCB alone, I have both in front of me. You have to give me a minute.
And we're probably buying like 1,000 at a time.
So, yeah, looks like we
He's
have
looking
a,
in the MRP system.
yeah, I need to go there. It may have been $4,
Yeah, that's a very expensive board. The
but
trouble is six layers isn't anywhere near as common as 4 anymore.
right.
Four's become not much more expensive than 2.
But why
And
don't you
you've got
guys?
a very heavy bottom layer too, haven't you?
We more than made up for the 4-layer savings through other components, though.
It wound up,
You
we
guys
probably,
need supervision.
yeah, we might have saved $1.50 or $2 on the PCB, but adding the other stuff made it more expensive. Like that TCXO is that like $1.60 or something? Or
Wow. Yeah, I'm paying cents for my crystal.
yeah, well, yeah, that's what our old crystal was 20 cents.
Oh, I think I'm paying 7.
Wow.
Well, I think, Ray, though, the idea is we want people to use the edge too, right? I mean, designing that circuit is something Chip just spent days with Michael on, for the second or third round. So hopefully customer would get the savings of using the edge.
Yeah.
And not doing all that layout. I don't know why anyone would do any of that layout over and over again when we can A, give them the layout, which saves them tons of time, or B, they could use the edge. Because most of these devices the P2 is going into are like up to 100 or 500 units.
Yeah.
Yeah.
I mean, that's really our fit. We're not the cheapest date or the cheapest supplier of anything.
You can't be. You've got to produce hundreds of thousands to get these stupid prices.
Right.
And I think someone asked on the forum, and I said, it takes me, I reckon, probably a half an hour per board to get my little boards out. Now, if you cost that out, that's half the cost of the board, price of the board that I'm selling. And you've got components and everything else, as well